Hey listeners, are you ready to uncover some extraordinary wonders? Disappearing Spoon is thrilled to partner with the amazing Curiosity Box. It's a science subscription service for curious minds. It's created by Vsauce, the internet's leading science education channel, with over 3 billion views. This season's box is packed with goodies that will fascinate and inspire you. Challenge yourself with a magnetic shadow alphabet puzzle. Piece it together to spell out the alphabet using only the letter shadows. Or discover the picture pot, where art and mathematics merge into a colorful, creative masterpiece. It is fun and educational. And the highlight, a sample of recreated Martian soil. Experience the thrill of holding the red planet right in your hands. Don't miss out on this unique adventure. Subscribe to Curiosity Box now and celebrate the incredible achievements of science. For 50% off, use the offer code SPOON at the-curiosity-box.pxf.io/disappearingspoon. That's offer code SPOON at the-curiosity-box.pxf.io/disappearingspoon for 50% off today. Unbox the mysteries of the universe with Curiosity Box. When the French authorities learned about the missing uranium, one terrible thought raced through their minds: that someone had stolen it to make rogue atomic bombs. They had good reason to worry. It was the early 1970s, a time of widespread terrorism around the world. During one 18-month stretch, the FBI recorded 2,500 bombings in the United States alone, 5 every day. Europe was just as bad, and it all culminated in the awful massacres at the 1972 Olympics. So yeah, people were paranoid about terrorists. Then French officials found out that uranium was missing from a mine of theirs in Africa. They naturally assumed that some terrorist group had upped the ante and stolen it. Enough was missing to make 6 atomic bombs. But they could not have been more wrong. Terrorists had not stolen the uranium at all. No one had. The truth was even wilder. In reality, the French had just uncovered evidence of the world's first and only natural nuclear reactor. From the Science History Institute, this is Sam Keane and the Disappearing Spoon, a topsy-turvy, science-y history podcast, where footnotes become the real story. The uranium in question came from a mine called Oklo. It's located in the former French colony of Gabon in Western Africa. The discrepancy at Oklo that first caught the French authorities' eyes was tiny, really tiny. Uranium comes in 2 main types: uranium-235 and uranium-238. Each type has the same number of protons in the nucleus of the atom, but they have a different number of neutrons. Uranium-238 has 3 extra. Now, uranium-238 is far more common. It makes up over 99% of all uranium. Uranium-235 makes up just 0.720% of uranium, and that percent is the same everywhere in the world, except at Oklo. In 1972, French authorities noticed that things were a tiny bit off there. Instead of uranium-235 being 0.720%, the concentration was 0.717%. That's a difference of 3/100,000ths. If you were measuring the length of a football field, that's a discrepancy of 1/10 of an inch. Other parts of Oklo showed somewhat larger discrepancies, down to 0.44%. But even then, you might be wondering, who cares? That's so tiny. Well, they did care. First, that missing bit of uranium-235 mattered because, of the 2 main types, uranium-235 is the dangerous one, the one that goes into bombs. And however small the percentage discrepancy, there were so many tons of uranium overall at Oklo that the missing bits added up fast, enough to make 6 bombs. So yeah, the missing uranium-235 was terrifying. But once they looked closer, French authorities noticed something odd. Wherever they found lower percentages of uranium-235, the surrounding rock also looked scorched, burned and black, like someone had taken a flamethrower to it. What could have produced so much heat? More importantly, the sites with the missing uranium had not been disturbed for over 1 billion years, which ruled out the idea that terrorists had dug up uranium. But then where had it gone? And what could have scorched the rocks? Not surprisingly, several fringe groups rushed into this vacuum of uncertainty. They began promoting Oklo as quote-unquote evidence of antimatter meteorites or crash landings by ancient aliens in star cruisers. Meanwhile, the scientific community began to ponder another idea, one that at first might sound no less crazy than alien star cruisers. But as Sherlock Holmes said, once you eliminate the impossible, whatever remains, no matter how improbable, must be the truth. And the truth is, Oklo was a natural nuclear reactor. The reactor arose due to a special set of circumstances 1.7 billion years ago. At the time, Oklo was a mud flat. The soil was soft clay with some uranium minerals mixed in. Then, for some reason, the site started flooding on a regular basis. Each flood, some of the uranium would dissolve in the water and trickle down into underground pools. Those pools contained algae, or pond scum. And when the uranium water trickled down, the algae pond scum would absorb it and thereby concentrate it. When the algae died, their tiny carcasses would drift down to the bottom of the underground pools and pile up, which concentrated the uranium even more. Eventually, the uranium grew concentrated enough to reach a critical mass, the point at which a chain reaction starts. These algae were the world's first nuclear engineers. But it takes more than a critical mass to get a chain reaction going. It also takes water. A uranium-235 atom will split in half, or fission, if it absorbs a neutron. And as it splits, that uranium-235 spits out more neutrons. These neutrons fly off and hit other uranium-235 atoms and cause them to split as well. That second round of splitting then releases more neutrons, which fly off and cause more splitting, and so on. That's what we mean by a chain reaction. One splitting atom becomes 2, 2 becomes 4, 4 becomes 8 and 16, and so on. But there's a caveat here. When a uranium atom splits in half, the neutrons fly out at absolutely blistering speeds, 8,400 miles per second. That's simply too fast for uranium-235 atoms to absorb. Neutrons moving that fast are like stones skipping across a pond. They just bounce off and keep going. The uranium atoms cannot absorb them. And when uranium atoms cannot absorb neutrons, a chain reaction never can really get going. So for a chain reaction, you have to slow neutrons down. And that's what water does. The speeding neutrons smack into water molecules and lose momentum until they're traveling much more slowly. Now, mind you, these neutrons are still going pretty darn fast, over 1 mile per second. But at that speed, uranium atoms can snag and absorb them. Then the atom splits and releases more neutrons and kicks off a chain reaction. That's why water is important. Another caveat to take into account is the percentage of uranium-235. Again, uranium-235 currently makes up 0.720% of natural uranium ores. That's 1 in every 140 atoms. But that percentage has changed over time. Our solar system formed 4.5 billion years ago after a big, horrendous space kablooey, a supernova explosion. That explosion created most of the elements on the periodic table, including uranium-235 and 238. And right after the big, horrendous space kablooey, the relative percentage of uranium-235 was high. Instead of being 1 in 140 atoms, it was 1 in 6 atoms, 17%. But uranium-235 is unstable. It decays naturally. In particular, it decays far faster than uranium-238. So over the eons, the relative percentage of uranium-235 kept sinking. It dropped from 17% to 16%, then 15 and 14, and so on. 1.7 billion years ago, the level of uranium-235 was 3%, and that's an important threshold. To get a chain reaction going, you need at least 3% uranium-235. That's why, in fact, modern engineers have to enrich uranium to boost the concentration of U-235 over the 3% mark. But 1.7 billion years ago, no enrichment was necessary. Natural uranium was strong enough. Overall, then, that's how French scientists explained the natural atomic reactor at Oklo. Water dissolved the uranium out of the clay on the surface, and it trickled down into underground pools. There, pond scum soaked it up and concentrated it. The water also slowed neutrons down enough to allow a chain reaction to start. And there was just enough uranium-235, 3%, to keep the chain reaction going. On average, the Oklo reactor provided 100 kilowatts of power, enough to run 800 big-screen televisions, 225 computers, or 25 clothes dryers, all driven by pond scum and water. And there's more. Uranium fission produces heat, which explains the scorched black rocks the scientists found. But how come there's not a big black crater in Oklo today? Well, because whenever the underground uranium got hot enough, the water around it boiled away. With no water, the neutrons started flying too fast for the atoms to absorb. So the chain reaction grinded to a halt, and new heat and energy production stopped. Temporarily. Because when the uranium cooled down enough, water trickled back in, which slowed the neutrons down again and restarted the reactor. In other words, this reactor was completely self-regulating, so it never got too hot. It was a nuclear old faithful, with on-off cycles of 3 hours, and it ran for 150,000 years, consuming 10,000 pounds of uranium before it finally petered out. Pretty darn amazing. Still, you might be left wondering something. If uranium concentrations were so much higher in the past, why aren't there other Oklos in other places around the world? Well, there's a simple answer to that. A simple answer with some profound consequences for the entire future of human beings on this planet.
When you need mealtime inspiration, it's worth shopping Kroger, where you'll find over 30,000 mouth-watering choices that excite your inner foodie. And no matter what tasty choice you make, you'll enjoy our everyday low prices, plus extra ways to save, like digital coupons worth over $600 each week. You can also save up to $1 off per gallon at the pump with fuel points. More savings and more inspiring flavors make shopping Kroger worth it every time. Kroger, fresh for everyone. Fuel restrictions apply. When you need mealtime inspiration, it's worth shopping Kroger, where you'll find over 30,000 mouth-watering choices that excite your inner foodie. And no matter what tasty choice you make, you'll enjoy our everyday low prices, plus extra ways to save, like digital coupons worth over $600 each week. You can also save up to $1 off per gallon at the pump with fuel points. More savings and more inspiring flavors make shopping Kroger worth it every time. Kroger, fresh for everyone. Fuel restrictions apply.
If the relative percentage of uranium-235 was higher on Earth in the past, why aren't there Oklos all over the place? The answer involves oxygen. Readers of my book, Caesar's Last Breath, might remember that the O2 oxygen molecule was a surprisingly late addition to Earth's history. Oxygen gas is simply too reactive to exist very long in a free state. Instead, it has to be continuously generated by living things, like algae, which release oxygen as a byproduct of photosynthesis. Because algae are aquatic, In ancient times, they released oxygen into the water around them. There, the oxygen glommed on to dissolved iron atoms to form a rusty precipitate that took the oxygen out of circulation. But 2.3 billion years ago, something shifted. There were suddenly so many algae pumping out so much oxygen that the iron in the ocean ran low. At this point, free oxygen began accumulating in the water. This buildup of oxygen in water was crucial. A few minutes ago, I mentioned that uranium from the clay mudflats at Oklo was dissolving in water. But honestly, that was a bit of a fudge. Uranium does not dissolve in pure distilled water. But oxygen changes the chemistry of water and suddenly allows water to dissolve uranium easily. This chemistry change allowed the uranium at Oklo to slip out of the clay and trickle underground. So the algae were not only concentrating uranium, they were producing the oxygen that freed the uranium from the mud in the first place. They really were nuclear engineers. Overall, oxygen levels help explain the lack of other Oklos. Even though the percentage of uranium-235 was much higher billions of years ago, the lack of oxygen in the water back then killed the possibility of concentrating that uranium into a critical mass. Only around 1.7 billion years ago was there enough oxygen. And after 1.7 billion years, the constantly dwindling percentage of uranium-235 on Earth sunk too low for a chain reaction to sustain itself. Oklo, then, was a perfect storm in terms of available materials and especially good timing. And again, there's more. The free oxygen that algae were producing eventually started to accumulate not only in the water, but in the air. This buildup of atmospheric oxygen had all sorts of consequences, including, eventually, the production of staggeringly large insects. You can hear about these insects in a short bonus episode at patreon.com/disappearingspoon. We're talking millipedes a yard long, dragonflies the size of seagulls, spiders as wide as car tires. It is wild stuff. That's patreon.com/disappearingspoon. This buildup of oxygen in air also had profound consequences for another form of energy on Earth: fire. Think about fire for a moment. What things do you need to start a fire? First, fuel, something to burn. Then, a spark of energy to kick things off. Finally, oxygen. But again, free oxygen did not exist for most of Earth's history, which means there weren't any fires either. Really. Even volcanoes and lightning strikes could not ignite anything without oxygen. We in fact see zero evidence of fire in the geological record until a few 100 million years ago, when the first black charcoal appears. That's the point when oxygen levels finally crept up high enough to sustain fire. Which sounds kind of crazy. When it comes to energy, we think about fire as ancient, primordial. Fire is deep and profound. But not really. Fire is a Johnny-come-lately. Which gets me thinking. Fire seems comforting in part because it seems ancient, our ancestors cooking around campfires and such. Meanwhile, atomic power seems scary and alienating, in part because it seems unnatural. But it's not. Mother Nature fired up the first atomic reactors a billion-plus years before fire ever existed. And consider this. The ultimate source of all life on Earth is the sun, which also runs on atomic power. In fact, all stars do. And stars are far more widespread than fire in the cosmos. We don't know of a single other spot in the universe besides Earth where any fire has ever burned, anywhere. Meanwhile, atomic-powered stars are everywhere. All of which should maybe influence how we think about atomic power. Now, I will admit my bias here. I'm kinda pro-nuclear power. Partly because I don't see radioactivity as artificial or necessarily scary. I mean, kitty litter is radioactive. So are granite countertops. Heck, even bananas are radioactive. Radioactivity is natural. It's all around us. Now, in saying that, I am not being cavalier about atomic power plants. Dealing with radioactive waste is a serious challenge. Accidents are a real problem, too. Chernobyl and Fukushima were awful situations. People died, people got cancer, and the surrounding land was poisoned. That's scary stuff. But do you know what's even scarier? Fossil fuels. Let's look at the safety record of nuclear power. Deaths from mining, accidents, etc. For every one person that dies due to atomic power, coal kills 344 people. Oil kills 258. Even biofuels like ethanol kill 64. So the stats are clear. In terms of sheer death, nuclear power is safer. And that doesn't even consider the destruction wrought by greenhouse gases. For every ton of greenhouse gas released by atomic power plants, burning coal releases 273 tons. Burning oil releases 240 more. Heck, wind and solar power release more greenhouse gases than atomic power. To me, our collective fear of atomic power looks an awful lot like some people's fear of flying. Plane crashes are dramatic and scary. There are fireballs and explosions, and everyone on board usually dies. They're terrible. But plane crashes are also rare. Meanwhile, car accidents happen all the time. They kill and maim thousands of people every day, every hour. But how many people are scared of cars? Because all that death comes in ones and twos, in dribs and drabs, we discount it. It's a cognitive bias. The same goes for atomic power. Accidents like Chernobyl loom in our imaginations like horrible monsters. They overwhelm our minds. And again, they are scary. But why do we fret about them and yet yawn at the thousands of people that are killed every year by coal and oil? Not to mention shrug at all the harm that burning fossil fuels does to the planet. It doesn't make sense. I suspect that, 100 years from now, future generations will be baffled at how much we loathed and feared atomic power. And arguably, it's more natural than burning fossil fuels. It's more ancient and more widespread than the fires needed to burn coal or oil. Meanwhile, even algae dabbled in nuclear power. Oklo may seem like a bizarre, ancient relic, but it also might be the best path forward for planet Earth. This is the Disappearing Spoon podcast, brought to you by the Science History Institute. Find out more about their library, museum, and multimedia magazine at sciencehistory.org. Make sure you check out the Science History Institute's other awesome podcast, Distillations. You can find their in-depth narrative stories and interviews about everything from space junk to sex, drugs, and migraines, anywhere you get your podcast, and on their website, distillations.org. You can find more incredible stories from my books at samkeen.com. You can also book me as a speaker at your school or event. If you like this podcast, please support it at patreon.com/disappearingspoon. It costs as little as 7 cents per day. You can also get bonus episodes and signed books. Please spread the word to others as well, and subscribe in iTunes, Stitcher, or other places. This episode was written by me, Sam Keen. It was mixed by Jonathan Pfeffer and produced by Mariel Carr, Rigoberto Hernandez, and Padmini Raghunath.
When you need mealtime inspiration, it's worth shopping Kroger, where you'll find over 30,000 mouth-watering choices that excite your inner foodie. And no matter what tasty choice you make, you'll enjoy our everyday low prices, plus extra ways to save, like digital coupons worth over $600 each week. You can also save up to $1 off per gallon at the pump with fuel points. More savings and more inspiring flavors make shopping Kroger worth it every time. Kroger, fresh for everyone. Fuel restrictions apply. When you need mealtime inspiration, it's worth shopping Kroger, where you'll find over 30,000 mouth-watering choices that excite your inner foodie. And no matter what tasty choice you make, you'll enjoy our everyday low prices, plus extra ways to save, like digital coupons worth over $600 each week. You can also save up to $1 off per gallon at the pump with fuel points. More savings and more inspiring flavors make shopping Kroger worth it every time. Kroger, fresh for everyone. Fuel restrictions apply.